Okay, today we are going to talk about the graphs of the reciprocal functions. So cosecant, secant, and cotangent. So the cosecant function, cosecant x, is equal to 1 over sine. So we're going to graph from negative pi to 2 pi. So in our calculator we should put y1 equals 1 divided by sine x. Now I'm going to go back and make sure that I'm in degree mode. There we go. Okay, so 1 divided by sine x. And I'm going to, the first time through, hit zoom trig. And here's the cosecant graph. Now, you should look at this as there's some undefineds because if you think about it, where sine is equal to 0, cosecant would be undefined. So where sine is equal to 0 over 1, cosecant would be 1 over 0. So let's check out what our table's at. I'm going to have my table start at negative 180 and go by 30s. And I'm going to change that window to go by negative 180 and the x max to go by to 360, and everything else is good. So now when I look at that table, so you know the sine of 180, negative 180 is 0, so the cosecant's going to be undefined. And you should see kind of a pattern there, negative 2, negative 1.1, negative 1, negative 1.1. Well, it's actually like negative 1.2, negative 2, error. So that's going to happen, okay? So looking at my new graph, that's what my cosecant should look like. Now, if I add in to y2 the sine of x, and I graph it along with the cosecant, you can see they do have 3 points in common there. And so it kind of tells you you've done it correctly because the sine of negative 1, the sine of 90 is 1, so cosecant would also be 1 because the reciprocal of 1 is 1. So going back to my graph, I'm going to set my x min at, like I said, negative 180, 360, the y min at negative 4 and the y max at 4. My table I had start at negative 180 and I had it increment by 30s. So I'm going to put in my asymptotes first. So this is negative pi over 2. This is negative pi, pi over 2, pi, 3 pi over 2, and 2 pi. And we're going to go 1, 2, negative 1, negative 2. X, y. Okay, so my asymptotes were at negative 180. And if you go back and look at the table of values, they're also at 0. The next one is also at 180, and the last one's at 360. Okay? So 0, kind of putting my asymptote in there, 180, and 360. Now that you can have your calculator open while you're looking at this, but negative 150 was at negative 2. So that's over here. And then negative 120 was at negative 1.2. And then negative 90 is at 1. Negative 60 was at negative 1.2 again, and then negative 30 was back down there to negative 2. So you're going to get arrows again that go along these asymptotes, just like that. And then you should notice that the same thing happens on the other side, except it's up above the x-axis. So at 30 degrees, you can check your calculator. At 30 degrees, it's at 2. 60 degrees, we're at that 1.2, and 90, we're at 1. And then the pattern continues. 120, I'm at 1.2, and 150, I'm back up to 2. So again, it's going like that. And then it goes back down when we get to pi, or 180 to 360. So that's going to be down here at -2 for 210. And then 240 is negative 1.2. Then we're back at -1, 1.2, back to -2. And that's it. So if I were to kind of sketch in the sine curve here, it would look like this. So in green, that one is y equals cosecant x, and the one in red is y equals sine x. So these are just the reciprocals, so this should make sense. Look at the sine is going from -1 to 1, so cosecant is now going to go in the opposite direction of that. And that's because they're reciprocals. All right, down to the secant function, we're going to do 1 divided by cosine. So I'm going to do 1 divided by cosine x. And then I'm also going to just put the cosine graph in. But first I'm going to turn that off. And it should be all set, the graph, so I'm just going to look at it from -180 to 360. It should look like the sine curve, but it's been shifted to the left. Okay, so, and that's what happens with sine and cosine. They're just transformations of one another, translation slides. So when we check out that table, there's 360. It's the same exact numbers, but notice that now the undefineds are at 270, -270. So 360 is, -360 is 1. There's an undefined at -90, so let's go and graph that. Okay, so again, I had some undefineds at -90, +90. This looks similar to what's going on with tangent. Okay, and then -180 was at -1, and -150 was at -1.2, and then we are at -2 for -120. So that's going to look like that. Then we go up into the we go up above the x-axis, and now at -60 we're at 2, and then at -30 I'm at 1.2, and at 0 we're at 1, and then this pattern repeats for 30 and 60. And then same thing on the other side. At 120 I'm at -2, and then at 150 I'm at -1.2, and then at 180 I'm at -1, and then that pattern continues again for 120 and for 210 and 240. And then for the at 360 we should be at 1. At 330, we should have been at 1.2. And at 300, we were at 2. So this one's going to go like that. And obviously, it would continue the looking like the parabola if we continued on. So if we graph now the cosine curve, there's our skeleton point, come down. Okay, there's that. And so then this goes down to like that. So there's our cosine curve, not my best cosine curve, so that's y equals cosine x. So again, they've got some points in common where it's equal to 1. And then this is y equals secant x. To go to the next page, and we have cotan, which is cosine over sine. Okay, but it's also 1 over tan. So that's what I'm going to graph is 1 divided by tan x. And here I'm going to do, it's actually, sorry, it's cosine divided by sine. Okay, so there we go. We should get the same thing. Now, a couple of things here, though. When you look at, let's have it start at negative 180. When I look at the table, okay, we see that for the cotan, it's got an undefined at negative 180, but it also says it has a undefined at negative 90 when I used 1 over tan. See how when I used 1 over tan it said error, but when I used cosine over sine, it's saying at negative 90 it's 0, which is in the y2 column of the calculator. So we need to be careful. It might be a better idea to just put into your calculator the cosine over sine if you're going to use the calculator to graph this. Okay, because back here, okay, the tangent of 90 is equal to 0 over 1. I'm sorry, it's 1 over 0. But your calculator can't like undo that and come up with cotan of 90 is equal to 0 over 1. So you have to know that. So it might be better to put into your calculator cosine divided by sine. Okay, because 1 divided by tan theta didn't really work out for us all that well, especially in the table. So the cotan of 90 is really equal to 0, so it's not undefined there. And that you will not get that. Okay, so when we go back here, if we do the cosine of 90 degrees divided by the sine of 90 degrees, which is what's going to happen if you do cosine over sine, the cosine of 90 is going to come out as 0 and sine is going to come out as 1. So in the table, you're going to get 0. So the better one to enter in is just the cosine over sine, so that we get at any of the negative 90 or the positive 90 that it says 0. Okay, so if we go down here, there you see 90 is 0. So we end up with our undefined in the right spots. Okay, so negative pi over 2, negative pi over 2, pi, 3 pi over 2 pi. Okay, so we had undefineds at negative 180, at 0, at 180, and at 2 pi. So I'm going to go by the 45s. So at negative 135, make this 1 into negative 1, negative 2. At negative 135, we should be at 1 for cotan. And negative 90 is 0. And at negative 45, we should be at negative 1. So it goes kind of the opposite of what the tan did. I didn't even put the tan up because the tan, if you graph those two at the same time, it gets very complicated to look at. So this one I do recommend just looking at cotan by itself. And then that pattern just repeats. So at 90 you're at 0, 45 you are at 1, and at 135 you're at negative 1. And same thing again, at 270 for cotan you're 0, at 225 you're at 1, and at 315 you're at negative 1. So there's y equals cotan x. Okay, so now let's take a look at amplitudes, maxes, mins, and so on. The amplitude for all of them was there is none because they just kept going up and up and up. There was no height. The maximum for them all was positive infinity because they had those arrows indicating they go on forever and ever into infinity, and so the minimum is negative infinity. And the period, if you look back at our cosine, or our sine and cosine, cosecant, our period, it looks like we get these two. You can't say that one single, looking parabola is one complete cosecant curve. It actually takes the downward one and the upward one. So it should be a period of 2 pi. And the same thing for secant. But if you look at cotan, these repeat every 180 degrees, or pi radians. Now the domain, kind of talked about the domain before. If you take a look at the domain for, let's go back a page to cosecant. For this domain, it's all reals except where it's going to be 0, 180, 2 pi, or 360, negative 180. Those actually are multiples of 180 degrees. So we say that our domain is x such that x does not equal n times pi. And remember, n is an integer. And that is the same for cotan as well. Look at your undefineds are at the same spots as they were for cosecant. So x such that x does not equal n times pi, or n times 180. And then if you look at the secant graph, that had its undefineds the same spots as the, I can't get back there, hold on. It had its undefineds the same spot as tangent at negative 90, 90, 270. So that one we've seen before. That is going to be x such that x does not equal pi over 2, which is 90, plus n pi. So it does not equal 90, and then plus or minus 180 from there, from 90. Now the range, if you look back at the range on cosecant, it was y was less than or equal to negative 1. It's an or y is greater than or equal to positive 1 because it did not meet in the middle anywhere. and secant was the same thing. And cotan was all reals. Okay, so we already graphed the sine and the cosecant together. All I need to do is look for answering these questions. Name 4 values of x in the interval for which sine x equals cosecant x. It might be a good idea for you to practice drawing it again, though, on your own. I'm going to go back and just put in here sine. So I'm going to do 1 divided by sine. And then I'm going to do sine again. And I'm going to change my window to go from negative 360 to positive 360 and take a look at that graph. So it asks name 4 values for which sine x equals cosecant, and you can see that they're hitting each other 2 times to the left of the y-axis and 2 times to the right. So my x scale is going by 90s, so it looks like it's hitting at negative 270, negative 90, positive 90, and positive 270. So negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2, or negative 270, negative 90, 90, and 270. And then list 2 values for which cosecant x is undefined. Well, there were a bunch of them. There was negative 180 or negative pi, 0, pi, any multiple of that, negative 2 pi, 2 pi. You could choose any 2 of those. All right, that is it for today. Have a good night.